Well, hello again, guys. We are back at the MCR Dynaero pickup, or ute as it's called here in Australia. I've got a fair bit of work to do on her. You can see she's left exactly how we left her. The turbo is off being repaired. I'll talk about that maybe soon. Yeah, I'll give you an update on it. Why don't I do that? And yeah, so the turbocharger called up the local Rotax dealer here in Australia, asked for a quote on the price of a replacement turbocharger for a Rotax 914. The quoted price was 9,000 Australian dollars. We were going to find another option. Considering a brand new 914, the whole engine is worth about $52,000. So a fifth of the cost of the engine is the little turbo that hangs down there. So I decided we would find a better solution. The better solution was to take the turbo to a turbocharger overhaul, repair, reconditioning service and have a look at it. And the turbocharger that is there, even though it's Rotax part numbers, everything, turns out it is a licensed version of a Garrett T25, which is a really, really famous, really, really easy to find turbocharger. So all of the parts off a Garrett T25 will go onto this turbocharger here. With one asterisk, it does seem that some of the seals, the internal seals on the turbocharger, are different between the Garrett and what Rotax put in them. So it seems like Rotax put an extra seal. And my instinct is that the different seal, it's an oil seal, I believe. It has an extra lip to it, or it's a slightly different dimension. And my instinct is that a car-based turbo, which these Garrett T25s are, has a lot larger tolerance for oil bypass or blow-by, which is the oil pressure and dictated by oil pressure, whether it's wet sump, dry sump, all of those other things. So that would be my instinct, is why there's a difference between the seals, is with an aircraft engine, the tolerances on everything around the engine are a lot tighter compared to a car engine, and that would extend through to the turbo. Is there going to be an issue with having a slightly different seal on this? No. We might see a slightly higher oil burn. This engine wasn't burning oil even when the turbocharger was broken. So it's not something that is really going to be a problem with this aircraft, and it's something we can keep an eye on. But I can't even buy that seal from Rotax. Rotax, the turbochargers are a non-service item, which means you have to take the whole turbocharger, send it back to them, and they give you another one for $9,000. It's not applicable. Again, this is an experimental home-built aircraft, so what we're doing with the turbo is absolutely fine. I didn't send the turbo to some backyard turbocharger overhaul facility. It's a fully accredited Garrett service center. They squinted and looked the other way when I told them what engine it was off, because they're obviously, one, not able to, because they're licensed by Garrett, they're not allowed to touch anything that Rotax built, and also they are not allowed to touch aircraft parts. So this isn't technically an aircraft because it's a home-built aeroplane. It's completely different, its own risk, all of those other things. And the cost of, the rough cost to have it completely, the turbocharger here completely brought back to OEM specifications is $800. So $800 versus $9,000 going back to OEM, and it's not an overhaul, it's a complete recondition. An overhaul would be replacing the compressor, the turbine wheels, all of those other things. But a full recondition means they'll measure all of the turbine blades, look for wear, look at the housing, if there's any wear there, and what they're replacing so far. So I was right. My instinct, if you remember from those videos, was saying we'll find things wrong there. Yeah, we were. The turbine shaft had quite a bit of wear on it, and it had that wear had started to destroy the oil seal. My instinct was it's coke. I haven't seen the actual turbine shaft, what they're actually doing is the turbine shaft is going to be oversized 10,000ths of an inch with a new bearing put in with an oversized 10th hour bearing. So the turbocharger will be coming back to as if it was brand new, oversized, and we're really lucky, really lucky that I was able to catch it before it destroyed itself some more. If it does, then it's, you know, compressor wheels, turbine housings, all sorts of stuff that needs to be replaced. So it's a really good positive step, and the turbo will be here probably after this weekend. But the turbo isn't why I'm here today. What we're actually doing is both of these main gear legs have not been serviced, and this gear leg here, I think I remember showing in a video, all of the seals on the Oleos. This is actually an Oleo strut, quite an advanced undercarriage on a light sport aircraft. Usually they're just steel. This guy here, full Oleo, it's leaking, it's got crap all over the Oleo strut, so I know this one's cooked. While we're doing one, we're going to do the other. So I am going to be jacking the aircraft up and removing these undercarriage legs. So I'm going to be cutting the video and showing different bits and pieces as I go, because it's only just me here, so it's a little bit of a risk to try and jack an aircraft up on your own. So I've bought some stands and I've bought a few other things to make it safe, and you can see I've already got the tail kind of supported up the back there. So I'll just make sure I'm not going to be completely under the aeroplane and putting myself at risk at any point. So yeah, but I'll show you how these gear legs come out, and then we'll get the gear legs over on the bench over there, and we'll strip them down, overhaul them. We've got an overhaul kit in that box there for all of the seals. I don't know if I have any fluid, but I should be able to find some. I don't even know what fluid's meant to be in here. It's probably MS5606, but what'll probably go in there is some other kind of hydraulic fluid, like some ISO 68 hydraulic fluid or something like that. It doesn't need to be MS5606, and 5606 is kind of shit, so we want something that lasts a little bit longer. So yeah, next time I'll bring you up will be hopefully the aeroplane in the air and me not stuck under it. Okay, so we're back a little whiles later. It's a little bit sketchy. I'm not quite finished getting the thing all hooked up here. I'll just drop down so you can see it was quite a bit of a... Sorry. I really should be paying attention to the camera. Sorry guys. So yeah, it's quite a bit of a battle to get this thing sorted. So basically I was jacking off the strut. Just cheekily jacking off the strut. But yeah, so I was picking the aircraft up off the main gear. You can see I've got the Oleo compressed right now, which is what was taking the weight off of this. So I'm not super happy about that. That means I'm going to need to just jack this side up here real quick and get rid of this block of wood here, because it's just it's holding the aeroplane up, and I really want this piece here to be holding the aircraft up, and there's no weight on this stand, and I need that to be the case so I can actually get this gear off. I think I'm going to be able to get this strut off by removing the wheel, and I'll show you that a little later. But yeah, this is the strut that's working well and didn't have many leaks, so that's why this strut's still working. The other side actually isn't. But yeah, you'll see what I need to do here is I'm literally just using my car jack. I couldn't find a bottle jack just onto the actual main strut that's there. It's a little hard with this lighting, I know, but the camera might work a bit better if I do that. Not really, but whatever it is, what it is. So I'm just going to take this weight off this block. You can actually hear that strut, all that noise. It's actually telling me that the strut that I thought was good probably wasn't actually as good as we thought. That means one of the valves in there is probably a bit corroded. I've got some crap on it. So yeah, all of that is fluid moving around. Okay, so yeah, now we can see that stand here is actually taking up weight. Wonderful. Still put that block there so the aeroplane won't fall too far. But yeah, all that noise that you heard was the fluid inside this strut here moving around. So I've got the aircraft supported in 4 axes, or 3 axes, I guess. So I've got the tail supported, I've got the centerline fuselage supported, and the nose gear I've kept on. I've just blocked it up. So it's a little bit, it was a little bit hard because I only had 1 jack. It'd be a hell of a lot easier if you have 2 people. You can pick the aeroplane up straight. But what I had to do here was pick up one side, set the stand, then pick up the other side, set the stand, pick up the tail, put the blocks under the nose, drop the tail, and then do the same thing again. Go up, tail, all of that. So I've been coming up slowly like this, and this should give me the height now to get this whole strut out of the wing. I'm going to need to take the wheel off first. And I've never done one of these struts, so I'm going to be figuring it out as I go. The manual just is really helpful. It just tells you to remove the gear leg. So yeah, I'll try and do that, but I'll take photos as I go so I can see where it goes together. So yeah, my next step, removing the main wheels off both of these. I'll probably start getting some of the brake stuff off as well, because I'll leave the brake stuff attached on the aircraft so I don't need to bleed the brakes. And then get rid of all of these cowls and all of that once the wheels are off. And then I should be able to start getting ready to remove it all. But one thing I'm going to do first is I'm going to stabilise each wing as well. You can see those 44-gallon drums over there. I think they'll just fit under the wings. So I'm going to get those. I'll get some cushions and stuff and put on those barrels over there. Put them under the wing, and that'll stop the aeroplane kicking itself off these sideways if someone tries getting in the cockpit or wiggling the wing or just bumping the aeroplane. So I'll secure the aircraft now that it's off the ground, and make sure that there's just no way it can flip itself off these jacks. So once these main gear is gone, if the plane falls over, it's landing on its wing and we're probably damaging lots of stuff. So aeroplanes in the air are scary. They're a high risk to damage themselves. So yeah, you can see those attachments all up there. So hopefully with a bit of luck, you can see where this, hopefully with a bit of luck, we'll be able to get these wheels off soon. But yeah, you can see where I've braced it, which is on the external fuselage supports, and that slot up there is where the main spar goes through. So the aircraft supported forward of the right on the forward spar. The rear spar is a little bit there. It's the main load bearer, but obviously still the front spar is quite strong. So yeah. Anyway, I'll come back hopefully with the wheels off. Okay, so as you can see, I've got one of the wheels off. I'm just going to do one side at a time. The way it looks like everything comes out is where the strut is here. I'll need to disassemble this strut on the bench. You can see the scissor links are there. And I've extended the strut just a little bit. What I have found is we're probably going to have a little bit more work to do now. This brake line here is just cooked. You might be able to see just up top there, there's a few bits of wear mark. And that's from when the strut goes to full extension. You see this piece here, that's like an alloy sort of fairing. And when the strut goes to max compression, well, you can kind of see that whole thing needs to fit up into there, and it just can't. So if you have a hard landing or like this, the strut's been sagging, this line, every time that the strut compresses, this line will get pushed up against that piece there. So remember, this piece here is what squeezes up. So this axle comes up into here, moves up, and well, where this bottoms out is about here. So if you can kind of imagine all of that bottoming out, well, where it bottoms out there, take this whole piece of brake line, and remember you can see there's a little bit of a radius there. So that whole length there is trying to fit into here.
but the line isn't run through there, so it just bends the line down, which is what it's been doing. So the whole brake liner is going to need to be replaced as well, which is going to be a colossal pain. But we'll see if it's any easier. You can see the brake line comes out up there, so potentially it'll be easier once this whole strut comes out. It's another good view up there of kind of like the socket that the strut sits in. You can see there's one bolt, there's another bolt on the other side, and it looks like after we do all of that, the whole strut will slide out through the wing. As long as I've got enough clearance under the aircraft, it'll all come out. And you can see the top of the strut. There's those two bolts. And you can see the top of the strut just up here. This is where the Schroeder valves are to put fluid in and pump it up. So I think that whole tube there is just going to slide out the bottom of the wing. As long as I have enough clearance underneath. So I might need to squeeze this strut back up again because I've got the wing thickness, and then I should be able to get this whole thing out here and slide it out under the aeroplane. So I'm going to go ahead and attempt that before I do the other side, to see if it works, because potentially the whole aircraft needs to come up a little bit further. And I still have clearance on these, but goes another little bit higher, it starts getting a little bit more sketchy. So I'll just keep working away on this, but yeah, just finding more problems as I go, which is very typical for an aeroplane that's, and especially this one's only done 300 hours, but it's existed for 15, 20 years, and these gear legs have never been brought out of the aircraft. So you can see one of the other problems, this is usually why I'm down here. It's usually a catch for most people, including myself, is have a look at these wheel pants here and see if you can tell. You can already see a problem is these covers, although this has come all the way down now, is I can't actually take this whole wheel cover off. The only way I can is if I actually slide it up over the top. So that's the other reason why I need to take the whole gear leg out. So there's multiple problems here. On some aircraft, like a Cessna, like a 172, the nose gear leg, if any of you have seen that being done before, the nose gear leg is you can undo these scissors, the Oleo scissors here, and you can just take the whole strut out at the bottom of the aeroplane quite easily. However, I can't do that because this whole panel, well, I could, but it would be incredibly difficult. This whole panel's kind of in the way, so I can't get access up into there. And even if I do, I actually need to then lift the aircraft up the whole height of the rest of the strut. So then I've got to get the aircraft up way above the ground, a lot higher, which is a more risk. Where at this point here is I'm only a little bit off the ground with the main gear legs. So what I was getting at is one of the problems is why this brake line problem was probably never picked up is because you can't actually see it. Because this thing comes in the way, so if you're just changing the wheel or changing the tyre or something like that, this cover is going to protect everything. So the catch it gets people is it's this stuff that you don't see and notice, because if you've jacked the aircraft up, taken the wheel off, the Oleo is uncompressed, so you're never going to notice this clearance problem with all of the stuff that's on the inside. So it's a common thing where when access is limited and you can't see something, that's where you're going to find a problem. So it's not coincidence that, I'll find another problem, I'll find another problem. The problem is, the thing I've noticed more and more as I've been engineering and getting older and more mature and grizzled, is I'll always find problems when I go, holy shit, that is so annoying to get into. I'll find a problem in there because someone else has done the same thing and they're going, oh, fuck, that's annoying. Maybe I'll deal with it later or whatever, it'll be right. So whenever I get that feeling now, that's when I start looking my hardest. That's when I go, you know what, the access here is absolute garbage. I'm not having a fun time. Well, I'm going to bet someone else didn't have a really fun time doing the same thing. I'm going to find something here that someone didn't notice. And so that's usually I tell myself is when I go, oh man, this is difficult, this is hard, or man, I don't have a lot of access. That's when I go, someone else has had this exact same problem and they were lazier than me. So I just need to be slightly less lazier than them, and I'll find a problem like this little brake line here. So yeah. Anyway, I'm going to keep going, and hopefully I'll be able to slide this whole thing out real soon. So yeah, we've got to get the nuts out here, and hopefully we'll bring the whole thing out. Okay, so it looks like with a little bit of gentle persuasion, I think this whole leg's going to come out. So I need to undo the brake line. We're going to get a little bit of fluid. I'll just show you this whole process of getting the gear out and see if I'm right. It does look like it's coming out after I've just taken those 2 bolts. So we'll just see how we go. I don't super like being under the aeroplane while I'm doing this. There's not a whole lot of room, and 2, those 44-gallon drums are a little bit big to fit under. So I'm not really feeling super happy being under here alone. Being under the aeroplane while being alone. Just disconnecting this brake line. Man, these panels are so annoying. All of this extra fiberglass probably saves half a knot, not even half a knot. It's not even any brake fluid anyway, so. Yeah, so as this strut comes out, we'll need to feed this line back up through it. But yeah, look, let's just see if we've got enough room to squeeze this out now without having to lift the aeroplane up. But I think, yeah, there we go. Oh, wonderful. Yeah, why this brake line wasn't run through the forward area, I'll never know. But of course, it's zip tied in. Need that thing to sit there and we've got some cutters. In all honesty, I just want to cut this brake line, but okay. Man, that gear leg's, she's pretty light. Pretty light, but the whole thing's out. Yeah, see, it's just got a fitting there. I'm gonna have to take this all apart on the bench, take the axle off and those scissors off to actually get any, you see just how annoying this is, maybe not. Is just getting all of this fiberglass off to access the strut. It's pretty annoying, but yeah, big hole in the wing. Be a good time for me to do an inspection in here as well, so we utilise this time the best we can. Okay, well, we've got this whole assembly up on the bench, which you can see is very annoying to deal with, especially this sort of wheel panel here, because the axle, if you're wondering before why this can't slide off, is because the width of that axle there won't fit through this top part here. So it's a very, very clunky design, but I mean, it kind of works, whatever. So my main step then is going to disconnect the scissors here, the scissor links, and then this whole strut I should be able to pop out. There should be a circlip up in the top there that retains everything. Some of them have a circlip, some don't, but we'll have a good look in there.
You can kind of see all of the crud that's up in here. So there's quite a significant amount of stuff, and you can see all of the leaks. That's all hydraulic fluid. Yeah, so the strut's definitely has definitely needed to see some love for quite some time. So, well, I'll undo all of this, try and get this whole unit out, then I can take this thing off. And well, I don't actually need to take this thing off. I really just need to get into here. It'll just be easier, but there'll be some packing and all sorts of stuff up in there. And yeah, I'll just be trying to keep all of the seals in order. So as I put them down, I'll remember what order the seals come out at, so I can see, and then I can put the new ones in. A little bit of a battle, but yeah, you can kind of see how it all works, so wish me luck. Well, I'm just starting to disassemble the port, the left side undercarriage. I've just stopped sort of halfway through it. There's not a lot of information in the maintenance manual how to do this. It's all in the build manual. But essentially you can see this is the socket that mounts up into the wing. And you won't be able to see all the way down there, but that hollow tube is where this strut actually slides all the way up. And it's actually this piston that you can see the back of there, it's actually retained here. So there's a pin that goes through there, and it actually retains that piston, which I've slid all the way down to here to get it out, is retained here. And that's what actually provides the strut movement. You can imagine this strut here, well, that piston, to be more precise, that piston is attached up there, and it's that silver strut that can slide in and out. And when I pull it apart a little bit more, you can see how it slides out. So there's, with an Oleo pneumatic undercarriage, like what this is there's two parts. There's the pneumatic side, which is the air pressure, and then there's the hydraulic side, which is the dampening, which is obviously the hydraulic fluid. But how those two things interact is up here in this piston. So there's air that sits on top, and then there is air that sits underneath, and it's those two that mix that provide the actual suspension. So there's no spring in this. Basically, the only difference between this undercarriage and say a motorbike front fork is a motorbike front fork would actually have a spring around this piston here, around that shaft. So there's literally the only difference. We don't need springs because there's not a lot of dampening required for, or like a lot of high frequency dampening required, because it's an aircraft. It doesn't spend a lot of time on the ground, or not enough to care about any kind of suspension. So there's no spring in here. Basically what sets the ride height is the air pressure and the volume of the hydraulic fluid. So yeah, the only difference between this and say a motorbike leg is literally there would be a spring between here and there's another piston kind of hidden on the inside there. So yeah, I'll get this undone a little bit more. The other piston that's in here, there's a little circlip that I've got to get out here with some circlip pliers. I need two hands to do that. Once that comes out, the other piston, so it's two pistons on either end of this rod, and once I get that one out, then I can completely remove the gear leg from the upper. The annoying thing with this whole setup is it's very French. No disrespect to any French people, but this wheel pant here, which is an aerodynamic cover, the only way you can get it on and off is if you remove this gear leg. So it's a little dumb. If you actually ever need to remove this piece of fiberglass here, you've got to take the wheel off and disassemble the whole strut. And you can't do that on the aeroplane because you'd have to lift the aeroplane up that high, like that much further off the ground. And even then that's not enough, because you've got to be able to get this whole thing out while it's on the ground. So the only way to take this fairing off is to pick the aeroplane up, take the undercarriage out, disassemble the Oleo, then you can remove this fiberglass carbon fiber fairing, and you can do whatever you need to do on it. But you can't get it up from the top because of this fitting here. It obviously just can't fit between there, and I've tried, but it's honestly a little bit of an oversight, real oversight, where it's like, oh, I'll never need to take this thing off. And yeah, you can see how cumbersome it is. Like, I've got this thing on my bench that I'm trying to do things with, and it's just, it's very French. You know, disassemble the whole aeroplane to take off a fairing which has absolutely no value whatsoever other than 0.5 knots of cruise speed. Like, it just, I would not feel, yeah, there's got to be a better way than this. Got to be a better way. Okay, after much gentle persuasion, and by gentle persuasion I mean using a broom handle and a hammer, I was able to get these guys all separated. So I thought I'd just take a moment to show you just how an Oleo works, just like this. It's maybe, I don't know, I'll just show you how it works. It's quite interesting because it's just a super simple system. So we've got the main strut. This surface here we want to have really nice and clean, because this is the main surface that is moving up and down. And then inside we've got the piston. You can see it's got two sides. This is the side of the piston that is attached at the very top of the strut. So this actually doesn't move. So once this piston, you can see those two holes that are just there, they kind of line up on each other, and that piston sits there. So from this section all the way down, and even all the way internal of this cylinder, because this cylinder has a hole in it as well, it is all like a vessel. So this is sealed all the way down. And we know it's sealed because there's no ring up here that's I've already removed. So this piece here doesn't move. It just lives right in there, inside the reservoir, or kind of like the fluid reservoir. And then it's this lower half is what moves. So this lower half, you can see the axles there. So this lower half sits inside this other tube here. And this is the guy that moves up and down. So this is what absorbs all of the landing load. So as the aircraft hits the ground, obviously the ground tries to drive this strut up. And if there was no fluid in here, obviously the strut would drive all the way up and slam up against itself. While this strut is moving up and down, this piston here is fixed. And you're saying, well, how does that work? Well, as I was showing you earlier, this guy here is hollow, but it actually has a wear surface on the inside as well. And that wear surface is so this piston here, I'm not going to put it inside because it's a really tight fit. As this strut here moves up and down with landing loads, this piston moves up and down. Well, technically the piston doesn't move, right? This piston doesn't move. The cylinder around it, I'll just demonstrate here, kind of moves up and down like this. And so this is where the hydraulic side of a pneumatic hydro-pneumatic Oleo strut comes in. As you can imagine, this tube here is filled all the way up, all the way to essentially the top here. It's probably a little bit below, with hydraulic fluid. So hydraulic fluid is obviously incompressible, so you can't compress it. So if we just filled this whole strut up full of hydraulic fluid, nothing would move. The strut would hit against the hydraulic fluid, it's incompressible, and we would have a strut that doesn't move. But what we do is we fill this to a certain level with hydraulic fluid and air. Well, let's just stick with the hydraulic fluid for the time being. So now as this piston moves up and down, or as the strut moves up and down, it tries to force hydraulic fluid against the backside of this piston. You can imagine if this was filled with hydraulic fluid and then the strut tries to move, well, this piston is resisting, it is giving some resistance to all of this hydraulic oil that's in there essentially. So this would be a hydraulic lock if there wasn't for some valves. And so in here we have some very super basic valves, and you can see they are literally just holes. They are holes, but they are angled and they are a very specific diameter. So if you're a motorcycle guy and you've heard a dirt bike guy and you've heard someone saying, oh, I need to get my forks revalved, is in most motorcycles, these holes actually are threaded and you can put different size orifices or like a calibrated hole in them, which allows a certain amount of hydraulic fluid to flow or to offer resistance to the fluid that's pushing up against it. So those little holes are what dictate how much fluid, as the aircraft lands, the wheels on here and the strut pushes up, those two little holes are metering or are slowing the amount of fluid that comes pouring out on the other side and pushing up into this area here, into this second chamber, if you like. So we have like a first chamber that's filled with hydraulic fluid when the strut's extended. And then as the strut tries to compress, it's trying to transfer the fluid from this side of the piston to the other side through those two little metered holes there. And so these have been set by the manufacturer in this aircraft case, so there's not much we can really do with it. But now let's talk about the pneumatic side, or the pneumatic side, the air, or sometimes what's used is nitrogen in here. And air, compared to any fluid, is obviously compressible. You can squeeze air, you can add pressure to it. And so the air pressure, as you'll notice at the top of this piston, is two little air valves. And those two little air valves, you can see they've got their little outlet on the other side that sits at the top of the strut. And those two little air valves is where we can add nitrogen or compressed air. And we add a certain amount of pressurized air into this top part of the cylinder. So we have pressurized air that is holding the hydraulic fluid down, but then that air pressure also adds some spring. So we're using air as a dampener in this case. So the air acts as sort of like a dampener, where this fluid that's rushing past this piston here as the strut tries to compress, that as that fluid comes into here, what's happening is this chamber, the actual volume inside is decreasing, right? So the strut's extended, you can see how much air we've got in here. Well, it would actually only be from this part to this part, so there's all this air. And then as that strut compresses, more fluid is being transferred from here onto this side, which is pressurizing this air even more. So I think with this, I was reading in the manual, it's about 7 bar of pressure. I don't know what that is in PSI, I didn't bother converting it yet, but there is a amount of pressure. I should know what it converts to, but honestly, whatever, it's a number. There's a certain amount of pressure here. And so that pressure, the more pressure that we start off to begin with, would change how high this strut sits. So this is when we're setting the aircraft up. You can imagine if I have not a lot of air pressure on this side of the piston, well, the aircraft's going to sag because the weight of the aircraft is going to pressurize or press on the strut, which will decrease this volume and have like a amount of pressure in here. But if I start off with a lot more pressure, I'm starting off with a higher pressure in this top section, well, it's not going to squeeze down as much. It's offering more resistance to this fluid coming this way past these orifices. So the strut, it's honestly super basic. It just requires a seal at the top, a seal at the bottom, a way of fixing this piston in there, and then measuring what size these orifices are. And then there's all other complexities like the density of the fluid that you're putting in here, the viscosity of the fluid, how it reacts with temperature. Because as you can imagine, this thing on a motorbike, when this thing's moving back and forward and up and down really, really fast, going over a road or bumps or anything like that, is the fluid's going to be going back and forward really quick here. It's going to heat the fluid up. And any fluid, nearly any fluid, that gets heated up, the viscosity changes. So the more and more you get it hot, the less and less viscous it becomes, the easier it is to travel. And so, again, back to the motorcycle guys that will change the valves, is they'll change their valves due to how hard they're riding, how long they're riding for, what the kind of conditions are. For us on an aeroplane, we're typically landing on a flat bit of ground, and the only thing we're really worried about is softening the impact on the aircraft when the aircraft lands. So as the aircraft lands, when there's no weight on the wheels, right, this strut will be at maximum deflection. I'm exaggerating it here. The maximum deflection is set by these scissors, but I'm trying to exaggerate how much it actually moves. So when the aircraft lands, we're trying to soften the load that goes on the structure, and that softening is the air pressure that's in here and the fluid that's moving. So as the aircraft lands, the wheels hit the ground, there's an initial shove, and that initial shove is resisted by those holes, transfers some fluid to the top section. This air pressure here increases in pressure because of the reduction in volume that's up here. And then what it's doing is, because there's more pressure here, it's trying to push the strut back that way, right? And eventually it finds its point of equilibrium. And that point of equilibrium is what we call the ride height, or the height that the aircraft sits off the ground. And typically we're aiming for actually about this much of the strut showing, typically about 50 to 60 mil, depending on what aircraft. So I'm going to keep going with this and keep disassembling it. I hope that made sense. Hope it wasn't too much of a ramble. I mean, I don't have the facilities to do infographics or any of that fancy stuff. So hopefully that will kind of make sense. But very, very, very simple setup. Some basic O-rings, some hydraulic fluid. In this case, this unit uses MS5606. And I was very, very, very close. MS5606 is a standard mineral-based hydraulic fluid that's used in aircraft. And I was very close to transitioning over to just a regular ISO 32 hydraulic fluid. It's easier to find, it's still fine on these seals, and it does the same thing. But it turns out one of the few things that I've learnt today, or one of the few things I've learnt a lot today, but what I've learnt today, and it is one of the very few things in aviation that is cheaper than anything else, and that is MS5606 hydraulic fluid. When I went searching for alternatives for hydraulic fluid for this case, basically everywhere in the automotive and motorcycle world was actually saying, go to your airport, buy some MS5606 hydraulic fluid. It's cheaper and better than the stuff we get for our cars at $40 a litre. So I spent a bit of time trying to figure out, maybe I could use some fork oil or something really fancy like that will really help it out. It will be a little bit easier to find. And in the end, it is maybe the only time I found an aviation product that is cheaper than a experimental type use hydraulic fluid. I could put something like automatic transmission fluid in here, but I can't get the viscosity down enough. And unless I could match how I was talking about these orifices being really important, unless I could match the kinematic viscosity as well as its viscosity index, I would have to mess around with these holes to get it right. And that sounded like far too much work, because as I was talking about earlier with the fluid changing temperature, as the temperature changes, the viscosity will also change, it will get thinner. And so matching MS5606 to a synthetic base, there weren't any exact matches, and the temperature range I'd be looking at is somewhere between ambient temperature and probably about 60 degrees Celsius, and I couldn't find one that would match, which would mean the hotter we get, the only fluids I could find that would be more viscous, which would mean they would be slower, so they would offer less dampening. So I went away from it. So anyway, long story short, your favorite Ryco 562, I think it is, or 762 Ryco, whatever it is. The cheap brand of MS5606 is the winner. And maybe put it in your motorcycle strut. I don't know, maybe. Anyway, I'm going to keep going. I've got to clean all this up, get it all cleaned, and giving you a bit of a look over it. I'm going to actually repaint most of this. There's a little bit of corrosion around here, same up here. So I'm going to actually just why everything's apart, just give it a quick scuff, put some primer on it, and make it all look pretty, and then it'll be a complete overhaul of the actual strut, left and right. So it'll look a little bit nicer when it goes back on the aeroplane, and I'll deal with some of this corrosion. There's actually quite a bit of corrosion down these struts here. If I can get the light in the right spot. I don't think I can. Maybe if I come over here. Yeah, you can see there right on top, there's quite a bit of corrosion on the top section where water's just been pooling, and there's even quite a bit here on the actual flange. So a little bit of work ahead of me. I will go ahead and get cleaning. Anyway, I'll probably leave the video at this point here. I'll probably just post this and I'll do another video of the reassembly because there's going to be quite a bit of time of doing this. I'm going to be rebuilding the brake lines as well, and I'm overhauling the brakes as well, so the actual slave cylinders. So I've got quite a bit of work to do, so just so I can get this video out, let you guys have a bit of a watch, and yeah, they're the struts. Have any questions, I'll be able to get to them before I reassemble it, and hopefully get this video up in the next day or two. Anyway, hope you enjoyed. Bye.